This is lesson 2.R.7, solving linear equations, this time of the form ax plus b equals cx plus d. We've got variables and constants on both sides of the equation. The first one actually doesn't have any constant on this side, but it's going to be the same thing. We need to isolate the variable on one side of the equation and then really get it by itself. But first, we need to get all of them on one side of the equation. Plus 2u plus 2u is the first step that I like. You could also do minus 7u from both sides and get it all on this side, all the variables on this side. But this way allows me to get to variable expression and constant expression on opposite sides, and then just one more step, dividing by 9. Negative 7 divided by 9 is negative 3, and that's u. U equals negative 3. It's a great way to say that, but you probably just have to put in the number into Hawks. For the second one, it gives me the equation 4x plus 3 equals negative 7, 8 plus 4x plus 32x. And for this one, it gives me 3 bubbles. Conditional. I'm going to abbreviate these in the future. Identity and contradiction. And we're supposed to decide which one of those terms applies to this. So the things to look for is a conditional equation has a solution. Sometimes more than one, but it's got a solution. An identity has an infinite number of solutions, and it's going to be, if it boils down to some nonsense like 3 equals 3. That's true, but that doesn't tell us anything. That's an identity equation. And if this equation tells me that two numbers that aren't equal are equal, then it contradicts itself. That's a contradiction. So let's see, by working with this, trying to solve it, what happens. The first thing I need to do is distribute. 4 times 3 is 12. Both sides, negative 7 times 8. 54. 56. Sorry. 56 plus, I'm going to distribute the negative also, so it's negative 7 times 4 minus 28x plus 32x. So that's just the result of distributing on both sides. Now I can combine like terms on this side. Negative 56 is the only constant, but 32x minus 28x is plus 4x. And here, 4x plus 12. Now my next step is going to be to get the constants on one side and the variables on the other side. I'm going to do it in 2 steps here. You can do it in 1 step, but the idea is if I, for example, add 56 to both sides to get 4x plus 68 equals 4x. Then this one more step, I could have done this one in the first place and it would have given me a different contradiction, but it says that 68 is equal to 0, and that's not true. So I know to select contradiction. This equation doesn't have a solution. I know this because this equation, step by step, led me to the contradiction that 68 equals 0. That's not true. So this can't be true either. For number 3, I got 12 times x minus 5 equals 2x plus 3. And again, it's the conditional identity contradiction. You don't have to write these, but since I do, I'm going to abbreviate them. But we're going to do the same thing. We're going to try to solve it and see what happens. I distribute the 12, and I get 12x minus 60 equals 2x plus 3. Now, what I'm going to do next is try to get the numbers on one side, the variables on the other side. But I can do that in one step. So the idea is this. I'm going to add 60 to both sides. Notice how I'm lining up the 60 with the 60 with the 60. I give 60, 60. But the numbers here are also lining up. And that's going to get this is going to go away. But I can also do this other step of subtracting 2x from both sides without interfering with each other. Now the next step is going to be almost completely simplified. 12x minus 2x is 10x. And that's all that's left on this side because the minus 60 plus 60 goes away. Over here, the 2x minus 2x, that was the point to get rid of that. Then 3 plus 60 is 63. And now there's just one more step, divide by 10 on both sides. X equals 63 tenths. And that might be something that you can put in to Hawks, but also it's even quicker to write it and type it as 6.3, which it's equal to. But I think either one of these is going to be okay. I need to select conditional equation because this equation, the given equation, is true on the condition that x is equal to 63 tenths. No other value of x makes this equation true. So this is the conditional equation. And when you fill in the dot for conditional, it should give you a pop-up box that you can type the solution into. The next problem I got is kind of strange, but it asks which is an identity from a list of 4 equations, and I'm going to just write the equations rather than writing the little dot because the little circle thing that they give you, it looks like a 0 when I write it, and I don't want that. But the first one was x minus 2 equals negative 2 plus x. I'm going to leave some space and write down x plus 5 equals x minus 2. The next one was x minus 2 equals x. And the next one was negative 2 plus 5x equals x. We're looking for the identity. Which one of these is identically true? And we can do that by doing the thing where we solve it. And if we get, well, let's see what happens. With this one, I'm going to add 2 to both sides and get x equals x. I could even go further than that by subtracting x from both sides, and it tells me 0 equals 0. Something like this isn't very informative, but it's true, and that's actually exactly what it means to be an identity. Is the equation is equivalent to a trivially true statement. So this is the one. This equation is the identity. It's possible that one of these could be, but they're not. And let's see why. With this one, I'm going to subtract x from both sides to get this, to do this one quickly. So what's left is 5 over here and negative 2 over here, and that is not true. But it came from this equation, which means this equation has no solution. It's a contradiction. So that's not the one that we're looking for. Also, this one, kind of the same thing. If I subtract x from both sides, it tells me negative 2 equals 0. Again, just it's absolutely not true. That means this equation can't be true. Contradiction. This one, if I subtract x from both sides, I get negative 2 plus 4x equals 0, and then add 2 to both sides to get 4x equals 2, and divide by 4, I get x equals 1/2 when I reduce that. The 4's cancel, 2 over 4 is 1/2. So that's the solution for this one. That means it's a conditional equation. It's not an identity, not the thing that we're looking for. So I don't think you have to check all of these. Once you find the one that you're looking for, that's the only solution. But watch for that in case there's more than one. For number 5, 3/8 times n plus 4/5 equals negative 3/8 times n minus 5. And I think the directions for this were just to solve. But even if it has us pick the 3, we still try to solve it to figure out if it's an identity, contradiction, or conditional. But what I'm going to do to keep this one a little bit more simple, we could distribute this 3/8 and distribute this negative 3/8. There's a better way to do this, which is to multiply both sides by the reciprocal 8/3. So if I am multiplying by 3/8 and then I multiply by 8/3, those cancel each other and leaves me with n plus 4/5. And I'm doing this because it's the same number on both sides and I can get rid of it quickly, because over here, multiplying by negative 3/8 times 8/3 is going to give me negative 1. I'm just going to say negative n minus 5, but the coefficient of negative 1. And that means when I distribute that negative, that the right-hand side is negative n plus 5. Now I'm going to do the isolate variable and number activity. Plus n to both sides. Let's do this one step at a time for this one, just to be careful with it. 2n plus 4/5 equals 5 is the result of that. Only the 5 is left. You can line those up if you want, but this is that fits side to side. And then finally, I'm going to need to subtract 4/5 from both sides. Oh, no, second to last is to subtract 4/5. That'll give me 2n equals, I'm going to put my 5 and then leave some space for the minus 4/5. Because I'm going to multiply by my conversion factor here of 5/5, that will give me the common denominator I need. So I'm multiplying the 5 by 5/5. The result is 2n equals 25/5 minus 4/5. Now they have their common denominator. I can find that value. 25 minus 4 is 21/5. And finally, I want to divide both sides by 2. But since I'm going to have to divide this fraction by 2, it's the same thing to multiply by 1/2. You can divide by 2, it just takes a little longer to work with the fraction. But if you multiply both sides by 1/2, 2 times 1/2 is 1. All that's left is n. 2n times 1/2. And then 21/5 times 1/2, I multiply the numerators, 21, I multiply the denominators, 10, and that's it. You could also write that, because the denominator is 10, this is easy to convert to a fraction. You don't even probably need a calculator. Tenths divided by 10 moves the decimal place once. For number 6, I got 3x minus 5 plus 9x equals 5x plus 7x minus 5. Like the other ones, it has the 3 bubbles with conditional, identity, and contradiction. They're not always in the same order, so it's not first, second, or third, but it's this one we'll see in a moment. If I distribute the 3x minus 15 plus 9x, and I distribute the 7 here, 5x plus 7x minus 35, I'm ready to combine like terms on each side separately. Here I've got 12x minus 15 and 12x minus 35. And I notice something happening because I've got the same variable expression on both sides. You might notice this before you actually see it. It says that negative 15 equals negative 35. And it doesn't. Not at all. I mean, if you multiply both sides by 0, you get a true equation, but that's not what this says. And it's not true, which means this one isn't true, or it can't be true, has no solution. And contradiction is I like to abbreviate it, but contradiction is the bubble that you need to select. Number 7 is another choose the type of equation. And of course, to find out which type it is, we solve it. And if it is a conditional equation, it has a solution, we've already solved it. So you just have to put the number in. This one, number 7, says 5 times x minus 8 plus 9x equals 6x plus 8 times x minus 5. And it's very similar to the last one. The first thing I'm going to do is to distribute here and here. This is 5x minus 40 plus 9x equals 6x plus 8x minus 40. Next, I'll combine like terms. 5x plus 9x is 14x minus 40 equals 14x minus 40. I'm trying to get the variable on one side, but what happens is if I try to remove it from this side, it also removes it from this side, and I end up with negative 40 equals negative 40, which is true, but not very helpful. And it doesn't say anything about the solution of this equation. It does say something about the equation itself, that it has an infinite number of solutions. Any value of x that we put in here will yield a true equation. So this is another example of an identity. And you'll see this kind of nonsense when you encounter an identity. Try to solve an identity and you'll get something like negative 40 equals negative 40. Like I said, true but not helpful. Not that all identities are not helpful, but the ones that we're seeing are not so great. This one is 5/4 v plus 1/6 equals 5/6 v plus 1/4. And I really don't want to do this the long way. I want to do this the quicker, graceful way. Not because it's graceful, because it's quicker, it's less writing. And that's to clear the equation of fractions. We can do this with an equation by multiplying both sides by the least common multiple of the denominators. And there's really only two denominators here, 6 and 4. They're on both sides, but there's still only two numbers. 6 is 2 times 3, and 4 is 2 times 2. So my least common multiple has to have 2 factors of 2, and also a factor of 3. 3 factors of 2, it's still a common multiple, it's just not the least common multiple, and I want to keep the numbers small if possible. So the LCM is 2 times 2 times 3, which is 12. And it's not a big factoring task, so I'm just going to use 12. What I'm going to do is multiply both sides of the equation by 12. And I am going to do this step carefully because it's easy to get confused on distributing, but it's what I'm saying is 12 times 5/4 v plus 1/6 equals 12 times 5/6 v plus 1/4. And what I have to do with that 12 is distribute it for both of them. If I distribute here, well, let's look at it one step at a time. 12 times 5/4 v plus 12 times 1/6 equals 12 times 5/6 v plus 12 times 1/4. So that's really completely expanded with multiplying by the LCM of the denominators, but also distributing it. Now we can focus on individual fraction expressions and what cancels. The 4 cancels with the 12, leaving a 3. So I have 3 times 5 is 15v. The 12 cancels with the 6, leaving a 2. So all that's left there is that 2 upstairs, the number 2. You can put a 1 down here, but you don't need a 1 in the denominator. 12 and 6 again cancel, leaving 2, so it's 2 times 5, or 10v. And then finally, 12 divided by 4. That's what I see here. But canceling the factor of 4 leaves a factor of 3. No more fractions. We've cleared the equation of fractions. So it's really, it's 2 steps beyond here. I'm going to subtract 2 from both sides to get the numbers over there. And I'm also going to subtract 10v from both sides. So what I'm doing here is 2 steps, but I'm saving writing by only writing the equation one more time. Over here, 15v minus 10v is 5v. The 2's are gone. That was the point. 10v minus 10v, that's gone. Let's get the variable over here. And over here, all that's left is 3 minus 2 is 1. So 5v equals 1. Too much space. And then divide both sides by 5 to get those to cancel. V equals 1/5. Or sometimes you have a choice, sometimes you don't. With Hawks and in general, the decimal version of 1/5 is 0.2. All right. The next problem is just another solve for the variable problem, and it's 9y minus 3.8y minus 6 equals negative 1.9y plus 6. So decimals, we've got decimals in this problem. That hasn't really come up a lot yet. So, but y, that's 1y minus 3/8y is negative 2, I'm sorry, minus 3.8y. 1y minus 3.8y is 1 minus 3.8 is negative 2.8y minus 6 equals, and over here, something different. I have to distribute that decimal. It's negative 1.9y minus, because it's a negative multiple here, 1.9 times 6. I don't really know that. 11.4. I got that from the calculator. Now I'm going to get the variables over to here and the numbers over to here. And it doesn't look too bad if I do plus 1.9y on both sides. Got to do it to both sides to keep it balanced. And then this number, I want to get over there. So we'll have variables and numbers. Here well, let's go from left to right. Negative 2.8y plus 1.9y is negative 0.9y. It's probably a good place to use a calculator. Plus 6 minus 6 is nothing. That was why we did that. But that's equal to, these cancel, negative 11.4 plus 6 is negative 5. Then finally, I'm going to divide both sides by negative 0.9 because that's my coefficient on y. Divide by negative 0.9. So this is y equals, and here's my solution. Well, they're both negative, so the result is going to be positive. Negative divided by a negative. You could think of this as 54 divided by 9. Which is 6. But 5.4 divided by 0.9 in your calculator is almost as fast. And that's the solution. The next one is also another solve it. 10 gives me negative 4v minus 6 equals 3v minus 20. And I'm going to do this one very fast. Getting the variable over to the one side. Subtract 3v for both sides. That's what I'm talking about. And then also getting the number over to that side, or all the numbers over to that side. What we're going to be left with is negative 7v over here. These cancel, and I have negative 20 plus 6, that's negative 14. And then finally divide both sides by negative 7, and I get v equals 2. That's it. So that was a kind of a quick one. Number 11 is also pretty quick. 3w plus 6 equals 4w minus 5. And I saw an opportunity here to save a step. Because we've got 4 here and 3 here, if I just subtract 3w, I'll end up with my variable on the right. It's not a real big deal, but the coefficient will be 1. And I won't have to divide at the end. It'll save me a step. What I get from doing that is 6 equals w minus 5. And then if I add 5 to both sides, I get 11 equals w, or w equals 11. The next problem I got was a really long word problem. And I'm not going to write it, and I don't think you should write it when you're solving it either. The thing is, from this word problem, you really don't have to build the equation. They give you the equation. So if you read the whole thing and ask what they're asking you to do, it's how many packages either store could hold. It's the number that you're looking for. Just solve the equation. And that's what I'm going to do. I'll read the problem though. 12 is about shoe store inventory, storage space or storage. And they say that Schuster's store needs 1,100 square feet for offices and 800 square feet for shipping. And Shoes needs 800 square feet for offices and 500 square feet for shipping. If Schuster's needs 4 square feet per package and Shoes needs 8 square feet per package, solve to find out how many packages either store could hold. I'm sorry, that's really, really wordy. But in this problem, they give us the equation that describes this situation that they're talking about. We don't have to build the equation. You could do it. It would take a while, but they gave it to us already. All we have to do is solve it. And the numbers are big, but they look like money numbers. They're square footage numbers. They're hundreds, not the x's, but we'll solve this for x first by combining like terms here. This is 1900 plus 4x equals, these can combine to 1300 plus 8x. Now I'm going to subtract 4x from both sides, and you could subtract 8x from both sides instead, but this will keep a positive coefficient. It really doesn't matter too much. 1900 equals 1300 plus 4x is the result. Then subtract 1300 from both sides. And that's 600 equals 4x. Divide by 4. And I get, I get x over here. The 4's cancel. And I get 600 divided by 4 is 150. I'm going to write it like this, x equals 150. But it comes from simplifying this and just simplifying this and reversing the order to put it in the normal order of things. For number 13, it said 7 times 2x plus 5 equals 4 times x plus 2 minus 4. And to solve this one, I'm going to distribute first on both sides. Here it's 14x plus 35. Here it's 4x plus 8, and then the minus 4. Now I can combine like terms over there, but oh, that's just 4x, but then plus 8 minus 4 is plus 4. If I subtract that 4x from both sides, I get 10x plus 35 equals 4, and then subtract 35 from both sides. 10x equals negative 31. And finally divide by 10. So x equals negative 31 tenths, which doesn't reduce, 31 is prime, or negative 3.1 is the decimal form of that one. Negative 31 divided by 10. For number 14, I have 0.7 times n plus 19 equals negative 2.8 n minus 1, another equation that involves decimals. So have your calculator handy there. I mean, that one anyway is really a 2-digit number. But let's see what we have to do with them. First, I'm going to distribute 0.7n plus 0.7 times 19, I did use a calculator for that, it's 13.3. And then negative 2.8 n plus 2.8. That's negative 2.8 times that negative 1, positive 2.8. Next, I'm going to add the 2.8 n to both sides. And let's just do that step. So 2.8 plus 0.7 is 3.5 n plus 13.3 equals, oh, well, this is gone, but 2.8 is still on the right-hand side. Next, subtract the 13.3. To get 3.5 n equals, I used a calculator for that one too, that's negative 10.5. And then finally, I need to divide both sides by 3.5. So n equals, that comes out to exactly negative 3. And then 15, 2 times 4 minus x minus 3x plus 2 equals 7 plus 4 times x minus 7. And there's some distributing to do, actually, in 3 places here. 2 times 4 is 8 minus 2x. Distributing this negative, minus 3x minus 2, then equals 7 plus 4x minus 28. Now I'll combine like terms where I can. Just because the constant comes first, 8 minus 2 is 6. Minus 2x minus 3x is minus 5x. That's equal to 7 minus 28 is negative 21 plus 4x. Next, I'm going to add the 5x to both sides. Another choice would be to subtract the 4x from both sides, but this will do, and it'll get the same answer. So they cancel here and leave just 6, and then over here I have negative 21 plus 9x. Now I'll add the 21 to get 27 equals 9x. Divide both sides by 9. Those 9's cancel, so I get just x over here. 27 divided by 9, it's 3. What that's saying is x equals 3. You could say 3 equals x. It's just, that's the more natural sentence order.